Let's talk about fertilization. So fertilization is a process of penetrating the oocyte, the sperm cell getting into the oocyte. And first, let's discuss a little timetable of when this is optimal. So one, the oocyte after ovulation is good for about 24 hours. You must have the sperm cell fertilized within 24 hours, otherwise it's not as viable. Your sperm cells are good for about 6 days. They can last in the female tract, okay? And it takes about 3 days. 3 days on average to get to the oocyte. But some sperm cells can get there rather quickly, actually. So you want to have intercourse a day or so before ovulation to get the sperm cell on its way to get to the oocyte. It has to go through the vagina, to the cervix, to the uterus, to the fallopian tube, to meet it in the ampulla of the fallopian tube. All right, and when typically the male ejaculates around 300 million sperm cells ejaculated, and around probably 3,000 or so make it to the end, get to the oocyte. So it's not really a guaranteed thing that it will work. It takes some effort to get there. Okay, all right. Now, another thing as well, something called capacitation. The sperm cell must remain in the female reproductive tract for 10 hours. 10 hours in the tract to allow for the acrosome to become more fragile. Okay, it allows the acrosome to release the enzyme. Otherwise, because these enzymes are digestive enzymes, they're really in a hard acrosome. But it takes time to make the acrosome more flexible, less sturdy, to allow for this reaction to take place, and it takes around 10 hours. So early sperm cells that can get to the oocyte very quickly will not be effective. You need to hang on for a while before you can start the process of fertilizing the oocyte. So let's talk about the steps of fertilization. Okay. So remember, the oocyte that's ovulated, it ovulates, comes out. Here's the oocyte. It's surrounded by a zona pellucida and by a corona radiata. Okay, so this is oocyte here. This is zona pellucida, and this out here is your corona radiata. All right. So step one is penetrating the CR, penetrating the corona radiata. To do this, so you have, again, the oocyte surrounded by ZP, and now the radiata. Here, hundreds of sperm cells will come in to attack the CR. So sperm cells. So the sperm cells have on the surface an enzyme called hyaluronidase enzyme. This enzyme on the surface of the sperm cells is what's used to degrade the CR. So it will degrade the corona radiata. That's step one. Then step two is now that they've gone through the CR, you must next make your way through the ZP. So here you go again. That out there is the oocyte. Here is your zona pellucida. And then out here is your degrading CR going away. So now the zona pellucida has on it receptors called sperm binding receptors. These receptors will grab sperm cells. So sperm cells can bind to these things. So in this step, sperm cells bind to your sperm binding receptors, which are attached to the ZP. And that will trigger an acrosomal reaction where the acrosome will release the enzymes to go in and digest through the ZP. So the acrosomal reaction happens here, where acrosome releases enzymes to digest through the zona pellucida. Okay. Then step three, now you have the oocyte is there, right? So step two is called penetrating the zona pellucida, right? Now step three is called binding and fusion. What happened here is this. So you have the oocyte is there. You have your ZP is there. It's being degraded in spots, being degraded a little bit. Okay. But now the oocyte is exposed. And the oocyte itself also has the sperm binding receptors on them. So as soon as a hole opens up in the ZP, one single sperm cell would bind to the oocyte. Only one is allowed to get through. Okay, so here, a single cell binds to the sperm binding receptor on the oocyte. And two, once that happens, then, let me just draw the oocyte by itself like this, right? Then the sperm cell will bind with the oocyte in such a way that the head and the mid piece go into the cell. So here, sperm enters the oocyte, or it fuses with it like that, called binding fusion. Okay. At this point, I'm gonna put back up your ZP around here. So it's still there. It hasn't gone away. Next, this triggers a cortical reaction where a barrier is formed between the oocyte and the ZP, like a watery barrier, so more cells cannot come in and get involved. Okay, so it's a cortical reaction to form what we call your fertilization barrier. Okay. And you also have enzymes that will destroy the remaining sperm binding receptors. So you destroy the sperm binding receptors on the oocyte, and you form a barrier between the ZP and the oocyte. So only one cell is allowed to get involved here. Any more cell is called polyspermy, and this would abort. And then, so step 1, so enter, so we call it A, B, this D. And then for C to happen, that's what I wrote on a small board here. So part C, here now, the oocyte, once it has the sperm cell in it, like that, then this cell will complete. So now oocyte completes meiosis 2 at this point. So now it's called an ovum. All right, so that happens there, and then the chromosomes mix. Chromosomes from the sperm and the oocyte mix after it's completed meiosis 2, and now now you have the egg still wrapped in its ZP, okay, but now it's called a zygote. So as soon as the sperm DNA mixes with the oocyte DNA, it's called a zygote, and you are now ready. Now you have a successful fertilization has occurred, and this will now mature to become the fetus and baby. All right, so we'll do that next. All right, so again, reviewing pretty quickly, you get through the radiata, get through the ZP, one cell binds to the oocyte. When it binds, it creates a barrier to get rid of all of the other potential sperm cells trying to come in. It also gets rid of the receptors there. And then the cell will complete meiosis 2, right? And then the chromosomes mix together, and now you have a zygote. And we'll go from there. Let's pause.